Well, good afternoon from Hong Kong. Got some things going on. I'm starting to energize and test a lot of these circuits that I've been running um, on the panel. And I'm kind of doing it a little differently than you normally would. Because what I've got is this side here is my inverter circuits. Now the AC output of the inverter goes straight to this main. This is my main, and it's an RDC. It's a ground fault main breaker, and then I've got my branch circuits after this. Plus, I've got my kilowatt meter that's on here. This is my main display, telling me what my AC volts and the amps that I'm consuming. Now, right now, I've just got my fridge on, and what's going on here in the cabin for the computers and stuff. So I've got 228 volts AC at 50 hertz, and right now I'm consuming between 0.2 and 0.3 amps. So now the way that this is going to work is this will always be on the output of the inverter, and then this side over here is my shore and generator. So I've got my main. So if I've got shore power, say if I go into the marina and I plug into the shore power, I would switch this over, and so the shore power would come in and energize these circuits. So like for an air conditioner or something like that. Or if I need to use my generator on, say, one of those typhoon days or weeks when we get like 4 or 5 days, just clouds, and again, that's off, then I would turn on my gen set, and then that will energize the shore side. Now this is a 32 amp main RCD, or ground fault, as some people know it. But now what it is now this first circuit that I have here is for the inverter. Now this is going to sound kind of weird, but the AC output from my inverter goes straight to this main but my inverter has a bypass. So let's say if I have shore power or the generator running, this will be energized, but what I can do is, let's see, I've got a bypass, because my inverter is an inverter. It's an actual DC charger for my DC battery banks, and I've got a bypass. So basically what that is on the side of my inverter, and I've got AC power can come in. So when AC power is sensed, which is an automatic sense, what it will do is it will bypass any pull from my batteries. It'll stop any pull from the batteries, and what it'll do is it'll start charging my batteries. So basically here I've got AC input. When this is sensed, it'll bypass pulling, and what it'll do is it'll come in and it'll go out. And that's why I have that breaker. So what I can do is the main output is always going to be here. But if I've got AC that comes out of, say, from the generator or the shore power, it'll go up to the inverter, bypass everything, and then come back. So I don't have to have any special switches in that. It's an auto sensing feature, and plus it's going to charge 60 amps. Excuse me, it's a 60 amp charger for 24 volt DC, 60 amp charger. And then that's how my system's working. So now I'm slowly getting things, activated. And we're moving forward, steady by jerks. So I need to get some power because I've got to drill some holes and stuff like that. So we've got a moderately sunny day. Again, I've only got 15 amps that are coming in, and from what I'm using, I've only got 1.59 amps that's actually going into the batteries. I'm consuming the rest of it, for the refrigerator there. But things are getting activated here, which is nice. And getting the DC, so it's taking a little time, but again, doing it right the first time. So that is what's happening, and it kind of looks good. Now, again, this is showing me power from the inverter, output of the inverter. Then this would either show the output of the genset or what the show or whatever I select that on. But that is how it's working. So, just wanted to give a little update on that. Little video for my documentation for restoring this old vessel. Alright guys, from Alan and May in Hong Kong, be good, be safe, and always be well.